All right, so in this first example, we're going to see how we can calculate the current that's going through this resistor X up here. It tells us that all three of these have the same resistance, and this is the current that's drawn from the battery. From Kirchhoff's first law, I know that the current that's going into a point, so the 0.3 amps that's going in here, is going to be equal to the sum of the currents, I1 plus I2. And we'll just call this pot branch up here the current I1. That's the current I want to solve for, right? What is the current in resistor X? But there's also some of the current that's going down this way, I2. So from Kirchhoff's first law, I have the 0.3 amps equals whatever the sum of these currents, or whatever these currents are, you know, they got to add up to 0.3. Okay, that's one piece of information that's true. Right now, we don't know the solution because for a given value of this, we could solve for this. We need more information. And that information is contained sort of in how much does this branch resist the flow of charge compared to this one. Okay, because this one resists the flow of charge twice as much, we know that the current in it is going to be half. Okay, so the current I2 is half of I1. And that's just another mathematical statement that we could write. Or we could write it, you know, sort of I1 equals 2 I2, right? Like this is twice as much current up here. So you could like multiply both sides of this by 2. 2 equations, 2 unknowns, just like we saw a moment ago. So now we have a solvable thing. So I2 is this, and so I have 0.3 equals I1 plus I2, but I2 is this, half of I1. So 1 I1 plus a half I1 is 1.5 I1. If we divide each side by 1.5, then we have 0.3 divided by 1.5 equals 0.2. And so the current that we wanted to solve for must be 0.2, as we mentioned earlier. You know, if it's a nice round number like this, you say, okay, 0.3, so 0.2 go that way, 0.1 goes this way, it adds up, and this one's twice as much as that. More formally put, sort of mathematically, these systems of equations solve. Then another one of Dr. Slice's worked examples. See you next time.